Hey guys, when you're testing Android applications with lock screens, the first thing that most of us check is an exported activity that skips authentication. And if you find one, you're in and you get the bounty. So for this crypto application right here, that's exactly what I'll try. As you can see, nothing. We can't get past the lock screen because, well, the check is there. And this is where a lot of us would stop. But that's the mistake. So what can we actually do to get past this? Let me show you. And there you go. We just abused a race condition and bypassed the lock screen. Let's go through exactly how this happened. By the way, if you're new here, my name is Richard and I spend a lot of my time breaking and securing Android applications. I also teach at Byteblind Security, so feel free to check it out. Alright, so if you're not familiar, every Android activity, which is just another word for screen, goes through a lifecycle. And two steps matter for this bug. On create is where the screen actually gets built, the layout, the button, all of those, and on resume runs right after. And that's where the screen becomes active and ready to use. Here's the actual code for our application. Clean up so it's a bit easier to read. So, on create builds the balance screen straight away and nothing has been checked yet. Then, when on resume runs, that's where the passcode check actually happens. If you're not authenticated, it starts the passcode screen. So hopefully that's pretty straightforward. Now, here's the thing. Calling start activity to start the passcode activity doesn't switch the screens immediately. It just tells Android, hey, go open the passcode screen, and then keeps going. It doesn't actually wait around for that to happen. So if you look at this diagram over here, when on resume runs, there is a brief window before the passcode screen actually loads. And that window, that's our chance to exploit the race condition. So if you know that tiny window exists, how would you actually exploit it? Well, turns out it's pretty simple. You just need to catch that window with a fast enough loop. Let's have a look. So what I'll do first is copy this ADB command to the terminal. And I'll create a while loop for this. And let it sleep for about 0.05 seconds for each call. That way it's not running too fast. Okay, that's it. So what we're doing is that we're trying to repeatedly launch the target activity over and over again, and fast enough so that eventually we land right in that window at the start of on resume. And the reason we want to do that is so that we're able to access that window when the protected screen shows before the lock screen. Okay, let's click enter. Alright, we can now see the protected screen behind the lock screen. And not only that, what if we try to interact with that protected screen? Let's try it out. I'll try to tap on the transfer button. And there you go. I was able to transfer some crypto from this protected application. So how do you actually fix this issue? Well, the real fix isn't about which lifecycle methods to check runs in. It's about not rendering anything sensitive by default in the first place. Just don't show anything sensitive by default. Keep it hidden or overlay it with something, and only take that away once the check has actually run and passed. So that's the whole bug. A lock screen that looks fine, but can be bypassed with a race condition. It's a small mistake, but a very common one. And I see this kind of weakness in a lot of applications when I'm testing. So that's it. If you made it this far, drop the word on resume in the comments, and this will let me know if you want more of these kind of videos. And if you want to see something even more impactful, I've got a video over here. It's about a zero-click bug that gets you shell by just being on the same Wi-Fi. I'll see you there.